It was while working in Melbourne as a management consultant that I met my co-founder Josh Tepper, a robotics engineer, and we got posed a question about whether a drone could be used to move chemotherapy medication in the Australian outback. We looked and thought the rest of the drone industry was trying to turn a toy drone into a delivery drone, and that we could flip that on its head by taking the 70-ton Hercules that I used to fly and Josh's robotic engineering experience and combine them to condense that aircraft down to a 25-kilo 3D printed electric autonomous aircraft.
With thousands of devices operating around the world, many at the same time, we knew we had to have a streamlined production process. This meant that every aircraft securely left our production facility with a unique key per device, and as they left, had a full digital twin of that aircraft within the cloud, such that they can constantly be monitored as well as updated to maintain those aircraft with cutting-edge technologies and improving the safety features of that aircraft. We wanted to do this in a manner that didn't require a technician in the field to perform updates, and we could efficiently do it around the world very easily. But what we needed to ensure that we did this in a secure and scalable manner. We worked with DS in pulling this together. Having DS as a trusted partner gave us access to their embedded specialists, so we could develop out a very secure IoT solution. Our IoT flight control process has been key in enabling us to be the first company to commercially fly a drone from outside of the country. Another capability we have in our service that we worked on together had safety at its core. Our aircraft fly what's called beyond line of sight of the pilot, out to remote regions. What we wanted to achieve to improve the safety of our platform was visually identifying and automatically processing, seeing a person or animal that was too close to our landing and aborting that landing. We worked collaboratively with DS to develop a solution to this.
We built a machine learning model, specifically a deep learning computer vision model, to detect humans and improve safety while the drones are landing. Unlike common human detection models where you might have a close-up view of the face for detection and facial analysis, or a full view of the side of the body for pedestrian detection scenarios, that top-down view from up to 60 meters above the landing area means that we often only get to see the top of the head and shoulders from above. Given the model needed to work while the drone is landing, and the drones are flying in some of the most remote areas around the world where connectivity may be limited, the drone needed to be deployed and work on the edge. We use quite a number of machine learning related services in AWS to build our overall solution. SageMaker Ground Truth and Amazon Augmented AI was used for data labeling and managing the workflow for human review. SageMaker Neo was used to optimize and convert the model for our target device. And SageMaker Pipelines was used to manage our end-to-end machine learning workflow. What we've built with Swoop Aero is really quite unique, pushing the boundaries of the cutting edge and setting the foundation for further computer vision scenarios in the future.
So what's next for us at Swoop Aero is bringing that technology from the far plains of Africa and the regions of Queensland and New South Wales back towards the cities of Australia and New Zealand and places like Indonesia and the Philippines, where we can transform people's lives by making delivery of critical services and essential supplies simpler than ever. As we look to the future, I'm excited to continue working with DS as we strive to make Swoop Aero's service accessible by 1 billion people in 2030.